JEE MAIN 2026, Question 21. Domain of functions. Here is the question. If the domain of the function f of x equals the square root of log base 0.6 of the absolute value of 2x minus 5 over x squared minus 4 is given as the union of intervals minus infinity to a, the singleton b, c to d, and e to infinity, then find the value of a plus b plus c plus d plus e. Let us recall the key concept. For the square root to be defined, we need the expression inside to be non-negative. Now, since the base 0.6 is less than 1, the logarithm is a decreasing function. So log base 0.6 of t is greater than or equal to 0 only when 0 is less than t and t is at most 1. Therefore, we need the absolute value of 2x minus 5 over x squared minus 4 to lie in the interval 0 to 1, inclusive of 1. Let us solve the problem step by step. First, identify the excluded points. The denominator x squared minus 4 is 0 at x equals 2 and x equals minus 2, so these are excluded. Also, when x equals 5 over 2, the numerator 2x minus 5 becomes 0, making the expression inside the log equal to 0, which is undefined. Now, the condition absolute value of 2x minus 5 over x squared minus 4 being at most 1 gives us the inequality 2x minus 5 all squared is less than or equal to x squared minus 4 all squared. We rearrange to get x squared minus 4 all squared minus 2x minus 5 all squared greater than or equal to 0. Applying the difference of squares identity, a squared minus b squared equals a minus b times a plus b, we get two factors. Simplifying, the first factor becomes x squared minus 2x plus 1, which is x minus 1 whole squared. The second factor is x squared plus 2x minus 9. So the inequality is x minus 1 squared times x squared plus 2x minus 9 greater than or equal to 0. Now, x minus 1 squared is always non-negative. So the product is non-negative when either x squared plus 2x minus 9 is greater than or equal to 0, or when x equals 1, which makes the first factor 0. Solving x squared plus 2x minus 9 equals 0 using the quadratic formula, we get x equals minus 1 plus or minus root 10. Root 10 is approximately 3.16. So x squared plus 2x minus 9 is non-negative when x is at most minus 1 minus root 10, or x is at least minus 1 plus root 10. Now let us combine with the excluded points. The base set from the inequality is minus infinity to minus 1 minus root 10, union the singleton 1, union minus 1 plus root 10 to infinity. Minus 1 minus root 10 is approximately minus 4.16, so minus 2 is not in that interval. Good, no conflict there. Minus 1 plus root 10 is approximately 2.16. Since 2 is less than 2.16, the point x equals 2 is not in the interval starting at 2.16. No conflict. However, x equals 5 over 2, which is 2.5, is inside the interval starting at 2.16. So we must exclude it. So the final domain is minus infinity to minus 1 minus root 10, union the singleton set containing 1, union minus 1 plus root 10 to 5 over 2, open at 5 over 2, union 5 over 2 to infinity. Matching this with the given form, we identify a equals minus 1 minus root 10, b equals 1, c equals minus 1 plus root 10, d equals 5 over 2, and e equals 5 over 2. Now let us compute the final answer. A plus b plus c plus d plus e equals minus 1 minus root 10 plus 1 plus minus 1 plus root 10 plus 5 over 2 plus 5 over 2. Notice that minus root 10 and plus root 10 cancel out. We get minus 1 plus 1 minus 1 plus 5, which equals 4. The answer is 4. Here are some G tips. Tip 1. For logarithms with base less than 1, remember that log base b of t is non-negative only when t is between 0 and 1 inclusive. Tip 2. Always check for excluded points where the denominator is 0 or where the expression inside the log becomes 0. Tip 3. When you encounter squared absolute value inequalities, the difference of squares factoring a squared minus b squared is very powerful. If you found this helpful, like and subscribe to MAGPIEHUB for more G solutions every day.